All right, continuing solving logarithmic inequalities. I find this one interesting. Logarithm by base 2, logarithm x by base 1/3 is less than 0. So, let's write down solution. Logarithm by base 2, logarithm x by base 1/3 less than 0. So from here I can say that 2 to power 0 is equal 1, right? So I can write down logarithm x by base 1/3 is less than 1, right? Since less than 1, no, and not to allow go beyond of 0, I'm putting here limitation greater than 0, right? Because logarithm cannot have negative number. X cannot be negative there. So from here, I'm going to do some, use some properties and do some changes, like change of base. Based on property of logarithm, so logarithm a by base b, here I'm going to change the base, it's going to be logarithm a by base c, and this base c you can choose yourself whatever you need it, and it's going to be logarithm b by base c. So I'm going to apply this property here. So I'm going to use logarithm x. I'm going to use base 3. Logarithm x by base 3 divided by logarithm x, logarithm 1/3 by base 3. Why did I choose 3? Because logarithm 1/3 by base 3, it's going to be negative 1, right? So I just wanted to get rid of the fractional base, that's all. Less than 1 and less than 0. So from here, we have logarithm x by base 3 over logarithm, I'm going step by step, 3 to power negative 1 by base 3, right? Less than 1, greater than 0. And then based on properties of logarithm, so if you have logarithm a to power p is equal p times log a, which means this power p comes in front, right? So I'm going to apply this property here, and I'm going to get, so this negative comes in front, and logarithm 3 over 3 is 1, right? So it's going to be negative log x by base 3 greater than 0, less than 1, right? And from here, if I get rid of this negative, so it's going to flip the sign, right? Sign of inequality. So it's going to be less than 0, and it's going to be less than, greater than negative 1. Because when we divide by a negative sign, it flips the sign of inequality, right? And from here, if I 3 to power negative 1, it's going to be 1/3, right? And 3 to power 0, it's going to be 1, right? So we are getting, let me write down nicely, and we are getting x is supposed to be between 1/3 and 1. X is greater than 1/3 and less than 1. So the answer is going to be X belongs to interval 1/3 and 1. Next, we have fraction 2x plus 3 logarithm by base 2 x squared minus 3x plus 3 greater or equal 0. All right, since we have here fraction, let's find out what is going to be our domain. First of all, conditions. 2x plus 3 has to be greater or equal 0 because it's under square root, right? We can't have negative sign. And from here, x is greater or equal negative 3/2. Second, the number under the logarithm also has to be positive, which means x squared minus 3x plus 3 has to be positive. To solve this inequality, we need to figure out the discriminant. That is equal b squared minus 4ac. To remind you, when a discriminant is greater than 0, then as a solution we have two x's, x1 and x2. x1, 2. When discriminant is equal 0, then we have as a solution 1x. Discriminant is less than 0. There is no the inequality have solution at any value of x. Any x. Okay? All right. So this is first condition, this is second condition, and we have third condition also. Third condition is we have to make sure that logarithm denominator is not 0, right? So which means x squared minus 3x plus 3 over by base 2 cannot be equal 0, which means from here, hence x squared minus 3x plus 3 cannot be equal 1, right? Because 2 to power 0 is equal 1. So it cannot be equal 1. So from here, we can say x squared minus 3x plus 2 cannot be equal 0. Okay, negative 3x plus 2 cannot be equal 0. From here, we can FOIL it. X minus 2 times x minus 1 cannot be equal 0. So x cannot be equal 2. X cannot be equal 1. So therefore, from all these domains, we can say, conclude that the area of definition for this entire inequality is x belongs to, so first one, let me write down here, let me show you. We have here negative 3/2, right? Next, what do we have here? This is 1. This is 2, right? And this is negative infinity. This is 1, this is 2, and here is positive infinity. So it's breaking down into 3 intervals, yes? What are these 3 intervals? First one is x greater than 3 over 2, right? And then next one is cannot be equal 1 and cannot be equal 2. Yes? And greater, in the third one, it's going to be infinity, from 2 to infinity, because of here we figured out, right, that x can be anything. X can be any value, right? All right. So this is going to be first interval, greater. We cannot take this side because x has to be greater than negative 3 over 2. Then we are taking between 1 and 2. And we are taking from 2 to positive infinity. So let me write down x belongs to square bracket because we have x greater equal negative 3 over 2, 1, or between 1 and 2, 1 and 2 in parentheses because 1 and 2 cannot happen, or 2 and positive infinity. Okay. So let's look the interval between negative 3 over 2, 1, and 1 and 2, and 2 positive infinity. The numerator of fraction for our inequality is positive. From here we can conclude that this inequality to be valid, we need that numerator and denominator would be positive. Yes? So since logarithm cannot be negative, therefore we eliminate two negatives and it's gonna be only positive logarithm, right? So therefore and top and bottom, meaning numerator and denominator, have to be positive. So let's see. 2x plus square root 2x plus 3, we already solved. We have it, x greater equal negative 3 over 2. And we solved logarithm, this is first one, greater than 0. And this one, let me solve also logarithm the same way. Logarithm, what do we have? X squared minus 3x plus 3 by base 2. I didn't put their log, I put LG, which is the same thing. You can use either log or LG, and it is greater than 0. And from here, we can say that x squared minus 3x plus 3 is greater than 1, right? Because 2 to power 0, right here. All right, and from here, x squared minus 3x plus 2 greater than 0. And which means it's the same thing I solved, but I solved as an equation. Now I'm solving as an inequality. And I will have x minus 1 times x minus 2 greater than 0. So solution for this inequality, it's going to be x minus 1 less than 0, x minus 2 less than 0, or x minus 1 greater than 0, x minus 2 greater than 0. From here we have x is less than 1, x is less than 2. So the answer is going to be, if I draw here, this is 1, this is 2, less than 1 and less than 2, we can see the answer is 1 is less than, x is less than 1, right? Accordingly, x greater than 1, x greater than 2, it's going to be x greater than 2. So the answer in this case is going to be axis belongs to from negative infinity to 1 or 2 and positive infinity. All right. Okay. So now to get the final answer, we need to compare this result we got here with where is it? With this one. Yes? Okay. And to compare and see what is going to be the common condition here, and that will be our answer. So what do we have here? Negative infinity and 1, and we have 2 and positive infinity. So in this case, if I compare, so we need to add the point negative 3 over 2, right? Let me see. I'm going to let me copy this, draw, and then we can put together all this. Okay. This one is here. And the result is going to be, what points we have? Negative 3 over 2, solid point, because negative 3 over 2 included. Then we have 1 empty circle, because 1 is not included. We have 2 that is not included, and positive infinity. Now in this case also 1 and 2, okay, everything is there. So let me shade this one first. Negative 3 over 2 and 1, this is going to be this area, and then between 1 and 2, this area, and between 2 and positive infinity. Now what I have here for this one, let me change the color of this one, and I color with same color on the graph so you can see. So between negative infinity to 1, which is going to be negative infinity to 1, right? And what we have, 2 and positive infinity. 2 and positive infinity is matching, but here is going to be, this piece is going to be common negative 3 over 2 and 1, yes? So this is going to fall out. It's going to be negative infinity, it's going to fall out, it's going to be limited by negative 3 over 2. So this way, what we are going to have, this 1 and 2, it doesn't have any overlapping here. This is also falling out. So common area is going to be this, right, to positive infinity, and this interval. And we are going to get, so the solution, practically, answer is going to be x belongs to square bracket negative 3 over 2, 1, or 2 and positive infinity. And this is going to be our answer. Okay, I'm done in this video, and I'll see you again in next video. Bye for now.